This conference will now be recorded.
Okay, so you know how to write Docker files and Docker commands. Now let us take one project. This is a microservice project like e-commerce. It has cart, payment, catalog, and then database like Mango and MySQL, rating, shipping, user, web service. All these are applications are microservice. We will install these applications. We will create Docker files, run them as containers using Docker Compose. And once we are comfortable with the Docker Compose and then containers, later we can install the same application into the Kubernetes cluster using manifest files. Okay, so let me clone this project here. Robot shop, and then it makes create it as robo shop for us. I can create directly in the GitLab. Okay, here let us create one new project. No, no. Robo shop public and clone this. Okay, first thing let us do with the web interface. This is the front end. I will copy this into our application. Okay, here let us remove this. We will write our own. Slowly we will improve. Okay, so this is a static application like our QI thing we discussed. Now let us create Docker file for it. So all static applications, we usually take a Nginx image, right? And then we add we add this to our user share Nginx and then HTML. Okay. So when you take Nginx image, it will automatically run. You don't need to write an CMD or entry point to make it run. It will automatically run. Now I will add it. Okay, I got it here. Web. Let me clone this in our server. You can switch off the server when you are not practicing, just stop it. So how you build Docker build -t web v1 dot. Okay, so it built it. Let us see Docker images. Web is there. Then how you run it? Docker run -d into detach mode. You are giving port. I can give 80 port web v1. Yeah. Now you see Docker ps. Okay, I have some world. Docker ps. Ours is running. Let us try to access this. Okay, so this is the front end of our application. When you click on login cart, it will call the other microservices. Okay, when you try to log in or register, it will give us some errors because it is calling other microservices to log in or register or cart. So we need to set up those services also one by one. Okay, so the other services we have is user, for example. This is for login mechanism, and then we have another example for cart. This will show you the items added. So when you see this application, there is server.js and package.json. If you have this JS files, it means JavaScript. It can be Angular JS or Node.js or plain JS or some else JS. But if you see package.json, this means it is a Node.js application. So usually these files are written by developers. They will give you full information. What is the language? What is the version of the what is the Node.js version? Everything. Then they also write the Docker files actually. If they face some problem, then you can tell them how to write it. Or in some projects, DevOps also will write Docker files for the applications with the help of developers. Okay, so it's a together. It's a mutual work done by DevOps and then developers. So by seeing this, let us do the cart first. Let us add the cart into our RoboShop. So they are taking Node.js 14 version, and let us remove this for now. They are exposing 8080 just for information purpose, and opt and then server. If you see this Docker Hub, we can get the full information of it. Node.js official verified. Okay, let us sign in first and then see. Node, okay. So we will have 14 somewhere. Okay, we have 14 version. You can see the description here. There are many other OS like Alpine. You can select the base OS. This is built like they will select one base OS. On top of it, they will install Node.js. Okay, but application developers, we don't care what is the base OS. We just need our application to work. Okay, that's it. And then we are changing the path to opt server. We can make sure it is created using this. Okay, now we are seeding to opt server. All the further instructions will run in this folder. We are copying package.json and then we are installing the libraries. So Node requires these libraries like dependencies, like Java requires some jar files. Node also requires some dependencies like this, and this is the version. This is the way we provide dependencies to the Node.js application, and this is the actual development file. Okay, Node.js file. And then we are installing the dependencies, we are copying the code, and we are running it. Okay, so this is a back-end application, not a front-end application, so we need to run the server. Hey, I hope you are aware of all these instructions. Okay, now let us push this code. and we will run it. Cd cart and then docker build -t cart :even dot. So this is installing dependencies inside our Docker image. Okay, now we successfully built. Let us run it. Docker run -t, and then we can give -p 8080, and it is also exposing 8080 cart v1. Okay, our cart is also running, but actually we need to connect these two applications. So somehow this application, front-end application, needs to know what is happening, how to connect to this cart, because it's a separate application. It's a this web is a separate application. We need to connect these two applications. Before that, let us discuss something about Docker Compose. For example, here we have 10 projects. Every time I cannot go and build one by one and then run it again one by one. So that's a difficult. Like you have a Linux commands. If I ask you to run 100 Linux commands, you need to run it one by one. Instead of that, you can write it in a shell script, and you will write the shell script. It will be done within a minute. So similarly, Docker Compose is a declarative way of running containers more than one. Okay, you whatever you give in this command, all the options you can give it in Docker Compose. Let us create one Docker Compose here. Docker -compose .aml. Okay, and then let us see one sample Docker Compose file. This is very simple. You don't need to learn it anything special. You just take it anything, open it. So this is how the syntax. We will see the syntax now. Services. Okay, everything is going to be services. I mean, all our Docker containers are going to be services. First, our service is like web. Now you need to provide what is the image I need to run. The image is web colon v1. And then you can mention the ports like this. Ports, I am mapping the host port 80 with container port 80. And then okay, here not everything listed. You can provide one name. You can see here container name. Container name you can give it as like web. And other thing is cart. Cart, what is the image of it? Cart colon v1. And then ports. Ports, it is already exposing 8080. We can give it as like 8080 here and then 8080. Okay, you can provide one name to it, container name, cart. Now it is running the names or some random dictionary names. Okay, yeah. So what I'm telling is this image to run, expose, attach these ports, give a name like this. Okay. So this is a simple Docker Compose. We can make it all the options. We can learn all the options in Docker Compose slowly. Now let me pull it. I will remove all the containers. Okay, now we have docker compose.yaml. How you run it is docker compose up. Up means it will run all the images you have given there. Okay, now you see it created the containers and it is running in the front end. I mean, it is not detaching the session. It is attaching the session to the terminal. Okay, and we are getting some errors because internally it is trying to call other applications. We haven't fully set up that. So obviously we get some errors. Control C, I'm stopping it. Now how to run it in a detached session is like just give -d. Now started, you can see your containers. Now the names are given as we have given. Names are coming as we have given, okay? And then you can see the ports it is exposing. Now let us build one by one and finally we connect all the applications. Whatever you see here, cart and categories comes from catalog. The catalog of the products you have. So like earlier, we copy catalog from this. Just like you did for cart, do the same thing here as well. And make directory -p opt server. Copy the package.json, install the dependencies, copy the actual code and run the node server. Okay, that's all. Oh shit, I ran it again. Sorry. /opt/server, copy package.json, install, copy the code, and then push it. Okay, now ours is ready. Let us build it. Docker build -t catalog :v1 dot. Before that, go to catalog. Now we built catalog. Now how to make it this catalog available in Docker Compose? Just write one more service catalog and the image you are going to use catalog v1, and then the ports. What is the port? It is exposing 8080. Okay, since we are using 8080 already here, let us use 8081 colon 8080, and then container name we can give it as catalog. Okay, that's it. So one application contains multiple microservices. So we use Docker Compose if you are running plain Docker. If you are using Kubernetes, no need. Now to down all your applications, just keep it as down. Docker Compose down will stop all the containers.
So while we are using Docker Compose, we cannot achieve high availability, right?
Docker Compose is just a declarative way of managing multiple containers, like stopping, starting at a time. That's it. Nothing other than that. Whatever you give in the terminal, if I ask you to run 10 containers in a Docker, you need to run the commands one by one. Instead of doing it every time one by one, you just write it in a one file and run it. Like you run 100 Linux commands, or you run a shell script which contains 100 Linux commands. Same Docker Compose. It's a simple command line utility. That's it. Nothing more than that.
Okay.
Okay. Yeah.
Yeah, hello, bro.
Now let us. Yeah.
Yeah, bro, can you open? Yeah, so this Docker Compose file is having all these names we are using, right? Like, can you open Docker Compose file, bro?
Yeah. Yeah. Opened.
So here, image, ports, container name, these are the default names coming from the Docker, or we can use any name, bro.
We can use any name.
Image also we can use. I mean, that not the name.
No,
Image
no.
instead of
This
image, we
these
can
keys
use any name.
these keys are standard. These keys are standard.
Okay.
See, this is equal to Docker run. You are mentioning image, right? Generally, and hyphen
Yes,
p
yes.
and hyphen name.
Okay. So those names can't be changed. Only the cart,
No,
web,
these are
catalog,
keys.
those names we can change.
These are keys. It should be standard.
Is
These
there
are
any
values.
alignment, bro?
No, it
I
is
mean,
like
we need to.
no, it can be. It can be. No need of any order. This is AML syntax.
Okay.
Order can
So
be
this is
anything, but
Docker
the keys should be
Compose.
standard.
Okay. The Docker Compose is coming into the picture when after image creation, right?
Yeah, correct.
After Docker
Exactly.
image
After image
creation.
creation. Yes.
Okay.
You need to build the
That's
images. So slowly
okay.
we will build the images using Jenkins also. Okay. First, when
Okay.
you understand these things manually, then we can go for CI part.
Got it, bro. Thank you.
Git
And Siva, sorry
pull.
to interrupt.
Yeah.
This particular file, this particular file name is a standard kind of thing. Docker hyphen compose. It's a standard file name.
Yeah. File name is standard. That should be
Uh,
Docker hyphen compose. Correct.
okay. And this file should be in the same path from where you are running the command.
No, it can
Directly.
be anywhere. It can be anywhere. You can keep it outside also.
Okay.
See,
Then
all the thing it matters is wherever you run, this image should be available. For example, if I run this, okay, I can keep it outside. Move. Okay, now it is not here. Okay, I added right now it is outside. What it matters is whether you have web colon v1 is available in this system or not. Okay, web colon v1 is available, and then catalog colon v1 is available, and then cart v1 is available. So Docker Compose matters whether the image is available in the server or not. That's it. Your Docker Compose can be anywhere. Just for to keep a track of it, and then for your purpose, I am keeping it in the same folder.
Okay, fine.
Yeah. Okay. Now I will move it because we are doing a lot of git pulls, right? This is a simple thing. Just your all everything is equal to your Docker run command. Whatever many options we have available in Docker command, we are keeping it here. That's it. Okay. Now let me. All our containers are running. We already down it, right? Docker compose up -d detach. That's it. Now all our applications are started. Okay. And let us check our logs. See, all applications we are starting, but those applications are not connected with each other microservice. How microservices are connected to each other is, for example, this web, when I click this register, it has to call user service through like http / user dot user slash something like that. If you see this inspect, see here. So this is not able to find this /API/user. The request is going to our web with /API. We need to connect those things like here. In in Nginx reverse proxy, right? So there will be a configuration whenever the Nginx gets this request /user /API/user, it is passing to the different service. So similarly, I need to make all these cart application, user, shipping, payment, ratings, catalog, everything available. And then I need to provide the reverse proxy configuration to the Nginx. Here our Nginx is like a web. So is it clear?
Yeah, sure.
Yeah.
Yeah. So now this catalog is calling MongoDB. You can see here Mongo network error. So for catalog to work, MongoDB should be available. Now we need to set up MongoDB as well. Where is it? What is the name? Mongo. Okay. Okay. Okay, we got this is MongoDB. Okay, we are just taking the MongoDB image. We don't care what is the base OS out of it. And we are copying our user.js. This is like some default data, and catalog.js. This is also some default data, some default products. So this MongoDB stores these products into its application. Okay. This is the default data we are giving it. Same. Push it. Now you see here, I am creating one more service, MongoDB MongoDB image. Let me create MongoDB v1 ports, and then container name can be MongoDB. One more advantage here is depends on. Catalog will give you errors when you don't have MongoDB. So first MongoDB should be up, then catalog will not give you errors. You need to, so your catalog is depends on MongoDB. If you don't have MongoDB running, then obviously you will get errors. Okay. So we will be facing a lot of errors. If you are facing errors only, you can know how to troubleshoot your applications. Okay. The port information. So clearly we know catalog is calling our MongoDB. Now let us see, don't give any port information, and let us see what will happen. Just give git full. Docker build -t MongoDB v1 dot. Okay, we built the image and we have a Docker compose as well. First, let us down all the containers. Okay, depends on must be a list. Okay, if you're not sure about Docker Compose, even I'm also not sure, you can just refer like this. The keys you can refer like this. Mostly we will use maximum 10 keys only. Okay, this is a list like this. So now what will happen when your Docker Compose is running? First it will create this, it will come to this cart, and it will come to this catalog. It will see depends on MongoDB. First it will run this, then it will run the catalog. Okay. Now Docker Compose up -t. The catalog is creating lost. Docker PS. Now you go and check the MongoDB catalog logs. Now you can see it is connected. Okay, initially it was not able to connect because it takes some time for the database to come up. Now it is connected. MongoDB connected from the catalog. Okay.
So in the Docker Compose file, if we mention the MongoDB configuration earlier than catalog, then that single error also will not be coming, right?
No, it is not like that. Compose will try to start all the containers at a time parallelly.
Okay.
Okay. We can define these dependencies very well while we are discussing other services also. Okay. And this is connected. Catalog and MongoDB are connected. Now we need to connect this catalog to our web cart to our web. Now if you see here, when we are clicking something, nothing is coming actually, because this is not able to call the other services, user and cart, whatever. See here, cart, it is not able, it is calling, but the configuration is not done. We need to do that configuration through the reverse proxy. Now you know, like referring something and then building it and doing it in a Docker Compose. It's not useful in the practical world. Mostly we don't use it. If you are not using Kubernetes only, we use Docker Compose, but mostly all projects are using Kubernetes. Then we will set it up in Kubernetes. But for interview, definitely they will ask, do you know Docker Compose? Depends on how you give port information. All these things they will definitely ask. Health check. You see, health check is also available here. Instead of writing health check in Docker files, we can write the health check in Docker Compose. You have the command also to start, like override the CMD. So everything is available here. Any doubts still here? Similarly, we can use user application. You can build user also. Then we connect all the user cart catalog to our front end. User.
Yeah, bro.
This is
So
also
I
same.
have some
Yeah.
regarding this.
Yeah.
So can you open compose file, bro?
Okay.
For example, I have first uh, three images, right? One is web and cart catalog and MongoDB. There are four images, right? We are running
Yeah.
containers, four containers, right? So for
Yeah.
example, in the web, if I mention the MongoDB, for example, the dependency on MongoDB, that will also work, right? If
Yeah. This will
the
also work.
MongoDB is okay, there is no matter, right, where it is MongoDB is available. Is it like
This
before or
name,
after?
whatever we are giving here, this name, MongoDB. When it sees depends on MongoDB, this should be here. Then only it
Anywhere
can
it
do
should
the
be.
dependency, right? Yeah, anywhere, it can be anywhere inside this file.
Okay, got it, bro.
Okay. Just finally, we have user service dependent on this, and then we can end up the session. Tomorrow we will connect it. I'm copying the user to this current directory only. Okay, we have the user, same thing, node 14 command. Docker file instructions are same, you know. I think this directory is already available. That's why it is able to move like that. Let us build this also. Similarly, you can give here user image. I'm going to give it as user v1. Container name is also user. Okay, but clearly, you know, your web is dependent on cart, catalog, everything actually. Correct? If backend services are not available, obviously you will get errors in the front end. So front end is the one that should be built last. Okay. Now front end is dependent on everything. User v1 and the port. This is also using 8080. Now let us give port. We are using our host port 808081 for catalog. Let us use 8082 for this. Okay, and that's all.
Hello. S1, I'm not able to hear you.
Mine also not able to hear. Your screen also not
I
visible.
think he's offline. Siva is offline because he told there will be some kind of maintenance in his place around 7:30. He told. I think that may be triggered. We may wait for
Yes.
another 5-10 minutes. If it's not coming back, then we can wind up the session. That's what I
Okay.
think.
Sure, sure,
Yeah.
sure.